All right, one thing you need to understand about the Pythagorean theorem, and when you're working through it, you can have some fairly basic problems like this where you're just dealing with some whole numbers, or we can have some more complex problems where we give you some radicals as either the legs or the hypotenuse of the triangle. So if you're watching this video, I would be under the assumption that you already have a pretty strong understanding of how to solve a problem like this. This is where you're getting stuck, is when you're getting these problems in your Algebra 1, Algebra 2 course. Okay, let's go through the basics real quick, make sure we understand that. If you already know the basics, feel free to just fast forward in this video to these more complex problems where I'll go over how to do them. All right, so we've got a leg here and a leg here. So a missing leg means I'm going to say a squared plus 5 being my other leg and my hypotenuse of 8. So a squared plus b squared equals c squared. We should all know the Pythagorean theorem by now. 5 squared equals 25. A squared remains. 8 squared is going to give me that 64. 64, I'm going to take away 25 from it. Take away 25 from 64, leaving me with a squared equals 39. We're going to take the square root of a squared to eliminate the exponent of 2, leaving me with a, which is this missing value right here, and it's the square root of 39. Square root of 39 can't be broken down any further than that, so we're going to give the square root of 39 as our answer. Okay, now that you've gone through one of these problems, let's go into something that's a little bit more complex. I'm going to go and explain how you go about them, what happens when you square root something like the square root, or excuse me, when you put an exponent of 2 above the square root of 21. All right, so first and foremost, we're going to say a squared plus b squared equals c squared. We know that 5 is the c because it is the hypotenuse, which is opposite of the right angle. So square root of 21 squared plus missing value, b squared, equals 5 squared. When you are square rooting something, the opposite or the inverse operation of that is to square it. So these two actually just eliminate one another, and it just breaks down to 21. 21. All right, now I got b squared, which is an unknown. 5 squared, which is 25. We're going to take away 21 from 25. Cancels. Leaving me with b squared equals 25 minus 21 is 4. We got to get rid of that exponent, so we use the inverse operation. We talked about that up here. Square root it to cancel. B is equal to 2. So we now know that this number right here for that leg would be 2 units. And for our last and final, let's kind of clear the board, give ourselves some space so that we can go over that. And we're going to be dealing with a hypotenuse now, written out as a radical. So I know that that's the hypotenuse because it is opposite of the right angle. So we're going to be saying unknown, a squared plus b squared, which is 4. So a squared is my unknown, plus 4 squared, which is this leg, equals my hypotenuse of 4 square root of 5 squared. Okay? So what's going to happen here? You've got a whole number in front. That needs to be squared. And we know that that exponent of 2 is the inverse operation of a square root. So 4 squared gives me 16. The square root and the exponent of 2 cancel one another out, leaving me with 5. So it's basically just 4 times this is now going to be 16 times 5. Over here, a squared remains a squared. 4 squared is going to give me 16, and it's equal to that 16 times 5. Okay, what is 16 times 5? 10 times 5 gives me 50. 6 times 5 gives me 30, for a grand total of, what did I say, 50 and 30, 80. A squared plus 16. Remove the 16 from the left side using inverse operations. A squared equals 64. And we get happy when we see numbers like that because we know it's a perfect square. Square root of a squared cancels the exponent of 2. Square root of 64 is 8. We now know the number that is missing for that leg would be 8 units. The Pythagorean theorem, basic, a little bit more challenging, bumping it up making it a little tougher on you. We can still handle ourselves. Study hard on this stuff, and good luck on your upcoming test.